The qualifier changes what this is called. Okay? If b is between 0 and 1, if it's 1, like in this case it's 1/2, that's called exponential decay. And you're going to see why in just a second, I hope. Okay? So if I have 1/2 to the, I'm going to go ahead and tell you we're going to use same old for our x's. Okay? We'll start with this one because that's the easiest one. What's 1/2 to the first power? Anything to the first power is just itself, right? So 1/2 to the first power is 1/2. What's 1/2 to the second power? So what's 1/2 times 1/2? 1/4, right? Okay? This is something I don't, respectfully, I don't expect you to understand today. I want it down on paper for us to be able to refer back to. Is that fair? Because we have the whole rest of the year together to make sure that you understand this. So can you just take it for me today? Yeah? Okay. So anything to the 0 power, what I want you to know is anything to the 0 power is always 1. So 1/2 to the 0 power is 1. 1/2 to the -1 power is 2. And 1/2 to the -2 power is 4. So -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4. Do you think you have a general idea of what this graph looks like? Okay, where's the x-intercept? I didn't give you too much of a pattern because right now there's only 2 that are there. I guess you can count this one kind of. But what's happening every time? If we start here and go here, what's happening every time? It's getting smaller by half, right? Am I ever going to get far enough up on the x's that I'm going to get to 0? No. So is there an x-intercept? No. If you'll remember back to yesterday, what's happening right here is that there is an asymptote. So nothing is going to touch the x-axis right there. Okay? Again, we're going to talk about that when we study specifically exponential functions. Okay? What about the y-intercept? What's the y-intercept? 0, 1. All right, what's the domain? How far to the left does it go? All the way. And how far to the right? All the way. So all real numbers. So negative to positive, right? How far down does it go? It goes to 0, right? But is it ever going to touch 0? So is there a way I can write that? Absolutely. It's exactly what I say. I say y is greater than 0. Now, the difference in the stuff we've done before is the other graphs that we did, they actually touched 0, right? So we had greater than or equal to 0, right? This one's never going to touch 0, so we're leaving it greater than 0. That means our interval notation still looks similar, right? 0 to infinity, but this time there is a parenthesis on the 0, not a bracket. Does that make sense? Symmetry? Is there any symmetry? So can I fold it this way? No. Can I fold it this way? Can I spin it 180 degrees and it's on top of itself? Not this time, right? So no symmetry. None. Highest point and lowest point? Good. None. And none. Where is it increasing? As I move across the page on my x values, where is this graph increasing? Nowhere. Where is it decreasing? Oh, everywhere. So basically my domain, right? So negative infinity to positive infinity. End behavior. As x is moving to the left, what's happening to the y's? It's going to infinity. It's going up, right? Now, this one, don't let it trick you. Ready? As x is moving to the right, what's happening to the y's? Where's it going? Down to what? Is it going all the way down? No, then I can't put infinity, right? Where is it going? 0. Very good. Any questions on that one? Now, you know this one's going to be similar, right? You know it's still exponential. Do you see, first of all, why this one's called exponential decay? Because why? What's happening from left to right? It's falling, right? It's decaying. The y values are decaying. So when b is greater than 1, what do you think is going to happen? It's going to grow. So guess what this is called? Exponential growth. Excellent. Okay, so to our table, -2, -1, 0, 1, and 2. Let's decide on a b value. What's the most popular b value that is greater than 1? Yep, 2. Exactly. So 2, which one's the easiest one to fill in? The 1, right? Because anything to itself is just 1. Let me say that again. Anything to the first power is just itself. So 2 to the first power is 2. What's 2 squared? 4. What did I say a minute ago about anything to the 0 power? It's 1. Again, I'm not asking you to understand this today. I want to get it written down. When we get to exponentials, you'll understand. This is 1/2. This is 1/4. Just as a quick aside, do you see a relationship between these two tables right here? Yes? Good. Okay. -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. Think you have a pretty good idea of what this graph looks like? Yikes. Why is that bad? Does the graph actually come back up like I drew? No, remember I told you yesterday I'm not great at drawing things that go to an asymptote. Okay. Where's the x-intercept? Again, there's not one, right? And where's the y-intercept? 0, 1. Very good. What's the domain? How far left? And how far right? Good. So all real numbers, or negative infinity to positive infinity. What about the range? How far down does it go? 0, does it get there? So y is greater than 0, or 0 to infinity, but with the 0 there's a parenthesis. Does it have symmetry? Nope. Is there a maximum point? A highest point? No. Is there a minimum point? Also no. Where is it increasing? As I move from left to right across the page, where is the graph increasing? Everywhere. So across the whole domain, negative infinity to positive infinity. So if it's increasing everywhere, where is it decreasing? Nowhere. Good. As the x values are moving to the left, where are the y values going? They are going down, but are they going all the way down? No, where are they going? To 0. Very good. As the x values are moving to the right, what is happening to the y values? All the way up, so positive infinity. Good? You seem like you're feeling a little bit more confident in this stuff, right? Okay, you seem to feel like you're getting a little bit more confident and kind of know what the words you're expecting me to say. Okay, and then I have to throw in these last two. So I'll apologize for that now. Okay? These are logarithms. This is called the common log. Common. Logarithm. Logarithm. And this one is called the natural logarithm. Do you see how this is written 10 with a little baby 10 down low? Or log little baby 10 down low of x? What you say is log base 10 of x. Okay? This one's written ln and x, but what it actually means is log base e of x. Okay? We'll talk about e later. Can you just trust me that it's a thing right now? Okay? So, you know how these two right here are related, exponential decay and exponential growth? These are also related, except where these are related because they were kind of backwards of each other, these are related because they're so similar. Again, this one's log base 10, and then this one's log base e. Just for argument's sake, I want to show you something really fast. This right here is what E is. E represents this number right here. Okay? You do not have to memorize that. I will never make you memorize that. But I do need you to know it's kind of around 2-ish. Okay? We're going to do a little something different here. Okay? Because of the fact that here you know what exponents are, right? You know what cubes are. You know, I could explain really quick what cube root was, right? Here we're not going to do tables so much, okay? Later on in the year, we will come back and fill in this table, all right? But here's what I want to do for you for this. I just want you to freehand it in there. The only thing I need you to make sure is this. This is a specific point. That 1, 0 is a specific point. I'm asking you to absorb a lot right now, I know that. Okay, so that's why I'm just asking us to sketch these two in right here. This one also goes through 1, 0, but it's a little higher above the x-axis. Got it? Is this enough to know x and y intercepts? Like having the graph, is that enough to know x and y intercepts? It is, right? Because you can see them, can't you? Where's the x-intercept of this graph? 1, 0. And where's the y-intercept of the graph? It looks a whole lot like this, right? Where it's just approaching that axis but never getting there, because there's not one. Same thing down here. The x-intercept is 1, 0, and the y-intercept, there's not one. Okay? Now, why am I doing these two at the same time? Like I'm filling this in and filling this in. Do you know? How similar are they? Very similar. Okay? So let's talk about domain. How far to the left does it go? To 0. Does it get there? It does not. So our x is greater than 0. So from 0 to infinity, but with the parenthesis. Is that the same for this one down here? It is, right? X is greater than 0 and 0 to infinity. What about the range? How far down and how far up? All the way, right? So all real numbers, negative infinity to positive infinity. Same for this one down here for natural logarithm. All real numbers first, negative infinity to positive infinity. Is there a highest or lowest point on either graph? No. Is there symmetry on either graph? Good. There's not. None? None. As I move from left to right, where is it increasing? Everywhere, right? So the whole domain is increasing. So from 0 to infinity. If it's increasing everywhere, where is it decreasing? Nowhere. So same down here, 0 to infinity, and none. As x is going to the left, where's y going? X is going to the left, y is going to negative infinity. As x is going to the right, where's y going? Infinity. Same thing down here though, right? Negative infinity and infinity. Got it?